Question 2. Find the acute angle between the planes with equations x plus y plus z equals 3 and 2x minus z equals 2. Okay, so from our two equations of planes, we can determine the two normal vectors to them. So let's make the first vector n1, and we know that's just going to be 1, 1, and 1. It's the coefficients of the x, y, z. So it's 1, 1, and 1. And the vector that's perpendicular to the second equation here will be x, y, z. It will be 2. 2's the coefficient. The y term doesn't have one, so it'll be 0, and this will be negative 1. Okay, so these are the two vectors that are perpendicular to our planes, and what we can then go ahead and do is find the angle between them using the dot product or the scalar product. So the scalar product says that cos theta will equal the dot product, so n1 dot n2 over the magnitude of n1, the magnitude of n2. Okay, so it'll be dot product, which is 1 times 2 plus 1 times 0 plus 1 times negative 1. And the magnitude of this will be root 3. And this will be the square root of, and it'll be 2 squared, 0 squared, and negative 1 squared. So 4, 0, and 1 will be root 5. So we're going to have 2 plus negative 1. So we negative 1 on root 15. So therefore, theta will equal, and we can use our calculator. So it'll be shift cos, and it was negative, actually this will be positive 1, because we had 2 minus 1, so it'll be positive 1. Okay, so 1 on root 15. So we get 1.31, and this is going to be radians. And if we wanted to get that into degrees, we could times that by 180 over pi. Or 75 degrees. So theta will equal 1.31 or 75 degrees. Okay, that's the acute angle between the two planes.